Welcome back to our second segment. We're still exploring current. Now we want to shift gears and look into exactly how do we measure current in as far as, a simple electric circuit is concerned. Because, the current reading must be an indication of how much charge passes through a point per unit time. So that's the kind of thinking that we must have. But also, forget not the big questions that we asked. Why do we exactly connect the ammeter in series or at a point? What's the justification? There is some scientific thinking around it as long as we understand the concept of current. Right, now measuring current in a simple electric circuit. Okay, we have already indicated that an ammeter whose symbol is that, okay, it's an A inside a circle, so that represents an ammeter connected at a point, okay, is a device that is used to measure current or strength of current. Okay, so take note, we talk of current in terms of charge per unit time, or we can talk of strength of current in terms of how much charge, the greater the amount of charge passing through, the stronger the current. Sometimes we may also alternatively refer to it intensity of current. So current, strength of current, current intensity, it may be used differently to refer to this quantity of current. It refers to the same thing, right? So the older version of the device, this is an analog one, which is an ammeter. In real life, it looks like this. So it has got two calibrations, okay? So when you connect it obviously at a point, okay? The black one represents the terminal where you place the positive terminal, while the red is the negative. And then you'd also realize that there are two calibrations or graduations. The other one ends with 1, the other one ends with 5. So when you connect to a circuit whose current you do not know, you obviously start with the bigger one, okay? The moment the current reading, that pointer deflects very, to a slighter extent. It says the amount of current that you are measuring is very little, it's below 1. Then you can change it and put on the middle one, okay? So this is just how an older version of an ammeter looks like in real life. But due to advancement in technology, because we are living, in the 4th industrial revolution now, we are having this version of a multimeter, which is digital. So this is digital, even in terms of, accuracy. This is more common nowadays. It actually gives you the reading electronically, so you don't have to, do the check between those calibrations and obviously widen the margin of error, okay? So that's our digital multimeter, right? But now let's look at measuring current in a simple circuit. Let's go back to our simulation, and now back to the simulation. Let's add another ammeter again here and see how we want to discover something very important about current. We'll add another ammeter onto this circuit just to get a sense of exactly what happens when current flows through a circuit, right? Okay, we'll take that apart just to try and organize it. Okay, there is our circuit. Okay, right. We can also try and understand that when current actually when the circuit is connected, the current that flows through a single pathway stays kind of the same. Okay, so here is our circuit. Okay, we've rearranged it and put two ammeters. Now in both cases there is 0 ammeter reading because there is no current. Why? The circuit is broken. But the moment we close, there is something very interesting. The first ammeter reads 3 amperes while the other one reads 3 amperes. Now in the point that we're trying to make, we are saying that the position or the connection of an ammeter in a circuit does not affect the total current in the circuit, which is why we say an ammeter is actually a low resistance device, right? Okay, now going back, it says the ammeter is connected in series. When we say we connect in series, we mean that it is connected at a point. the idea is to establish how much charge passes through that point per second, okay? So if we go back again, we would also understand that the two ends of the ammeter, because even if we represent it symbolically, we've got an ammeter, one end is connected to the positive, the other end is connected to the negative terminal, right? Okay, so we have managed to measure our current, but there's something again about current that I want us to kind of discover now, okay? Which is something that we already know, right? Now, what happens if the ammeter reading changes or whatever would have happened? I just want us to look at the, you know, the brightness of the light bulb, okay? Now, we'll start with something that we know from our earlier grades. We'll start with a current of 1 ampere. Just check the brightness of the bulb when there is current of 1 ampere. By the way, what did we say is an ampere? It is when 1 coulomb of charge passes through every point per second. So there's that number, 6.28 times 10 exponent 18 electrons passing through a point for every second. As you can see, that's how current is flowing. Now, what if we increase the amount of current? We also want to check the brightness of the light bulb, okay? Let's increase that to say 3. Okay, we double the current. Okay, look at even the rate of flow. It means now these charges are moving even faster. As the charges move even faster, what happens to the brightness? Now the bulb glows even brighter. So current strength is an indication of how much charge passes through a point. Now from 1 ampere to 3 amperes, so it's 3 times as more amount of charge passing through that point per second. So the greater the amount of current, the greater the number of charges passing through a point per second. And when we talk about a second, we're talking about 1 second, which is a unit of time. Let's make it even more and see what happens. Let's make that, say, 12 volts, okay? You can see even now it's 4 amperes. 4 amperes, even brighter, okay? So now there is some relationship that exists here. You know, the greater the magnitude of amperage or current reading, the more the quantity of charge passes through a point per second. And why do we continue to emphasize a point? Yes, we connect the ammeter in series or at a point because we want to know how many of those coulombs of charge actually pass through that point for every second. Right, let's go back to our simulation. Okay, so we can now relate the current to you know, the intensity. So hence we spoke about strength current, which says, okay, if we've got 3 amperes, this current strength is greater compared to that of an ampere, which is 1 ampere. We also saw even how fast the rate of flow. So it goes back to the definition, which says current is defined as the rate of flow of charge. So the greater the current, the greater the rate of flow. Hence, we would see even the brightness, meaning that even the amount of energy, you know, transferred, per coulomb of charge is greater because we kept on changing, and then we also realized that the brighter the bulb glows. Okay, in the second segment, we'll look at the concept of current in terms of, you know, the mathematical calculations and try to bring in some form of understanding to say, okay, how does amount of charge affect the current in a given amount of time? Okay, we'll take a short break for now.